The summer heat poured down on the flat Ohio landscape as Robert Walker climbed the metal stairs to Wright Field's Aircraft Evaluation Building. It was late June 1943, and the war, though still distant from American shores, had begun to deliver its lessons through captured aircraft. The facility near Dayton hummed with activity, engineers and test pilots moving between concrete hangars that stretched like grey monuments across the airfield. Walker, a structural engineer with North American Aviation, had been reassigned here just weeks earlier with a specific mission: to understand why a German fighter had terrorized Allied bomber formations across Europe while American escorts struggled to contain it. The aircraft had finally come into their hands, and now the real questions could begin. The Bf-109 G6 tropical variant sat in the dimly lit hangar like a skeletal trophy, stripped of its camouflage and insignia. Its serial number, Werknummer 16416, told a story of its recent past. This particular machine had been captured in North Africa at Soliman Airfield in May 1943, after being abandoned by Luftwaffe mechanics fleeing the advancing Allied forces. It belonged to Jagdgeschwader 77, one of the premier fighter units defending German interests across 3 continents. The aircraft had been carefully disassembled, crated, and shipped across the Atlantic. North American own technicians in Los Angeles had supervised its reconstruction, piece by piece, back to something approximating flight condition. Now it was Walker's turn to unlock its secrets. He stood before the aircraft as the morning sun cut through the tall windows, catching the intricate details of its construction. Even at rest, the Bf-109 possessed a certain aggressive elegance, a quality that seemed to emanate from its compact frame, like heat from concrete in summer. The fuselage was remarkably narrow, almost cramped by comparison to the P-47 Thunderbolt that dominated American fighter squadrons. The engine, a Daimler-Benz DB605A, producing 1,455 horsepower, sat deep within the airframe like a mechanical heart. But what struck Walker most immediately was the landing gear. Those splayed legs, angled outward at an odd geometry, seemed almost precarious. An engineer standing beside him, Arthur Henderson, tapped the fuselage thoughtfully with a pencil. "Willy Messerschmitt knew exactly what he was doing," Henderson said quietly. "Look at how it's all concentrated here." He pointed to a massive forging bolted to the firewall. "The engine mounts, the landing gear pivot points, the main wing spars. It's all connected at one point. Beautiful from a manufacturing standpoint. Terrible from a maintainability standpoint if anything goes wrong." The Bf-109's design philosophy was fundamentally different from American thinking. While the aircraft corporations of the United States believed in distributing loads across multiple structural points, making repairs easier and damage more survivable, Willy Messerschmitt and his chief engineer Robert Lusser had pursued an opposite path. They had taken the smallest possible airframe, barely large enough to house a pilot and an engine, and wrapped it around the most powerful inline engine available. This approach meant simplification, reduced weight, and concentrated manufacturing efficiency. The wings could be removed for transport or storage without any special supports. They simply detached from the fuselage because the loads were handled by the central firewall structure. It was elegant. It was revolutionary. It was, the Americans were beginning to understand, a design that had strengths and profound weaknesses. Over the next 3 weeks, Walker and his team conducted a systematic examination that would become legendary among American aviation engineers. They measured, photographed, and sketched every component. They traced wire runs, noted the placement of fuel lines, examined the cockpit layout, and they discovered things that puzzled them. The German designers had solved certain engineering problems with solutions that were brilliant and bizarre in equal measure. The fuel injection system on the Daimler-Benz engine, for instance, was far more sophisticated than the carburetors used in American Allison and Rolls-Royce Merlin engines. Where an American engine would hesitate or fail when inverted or pulled through extreme maneuvers, the German fuel-injected power plant continued to deliver fuel with mechanical certainty. The Bf-109 pilot could roll his aircraft upside down and maintain power, a maneuver that would starve American engines of fuel and force pilots into involuntary dives. But fuel injection was not the only innovation. The propeller mechanism was mounted to a complex series of linkages that allowed automatic pitch adjustment. The blades could change angle based on engine speed and air pressure, finding the optimal position without pilot intervention. The supercharger was integrated into the fuselage in a way that reduced drag. The metal surfaces were carefully shaped to minimize parasitic resistance, and the engine itself was installed with a kind of mechanical obsession for alignment and vibration damping. Every detail had been considered. Many had been optimized to a degree that made American engineers shake their heads in quiet frustration. Here was a machine designed by people who understood aero engines and had been given nearly a decade to refine their understanding through actual combat. Yet, as Walker moved from observation to deeper analysis, other facts emerged that contradicted this image of German perfection. The cockpit was surprisingly tight. The pilot sat in a cramped space surrounded by instruments that seemed haphazardly arranged by comparison to American designs. The canopy, which hinged to the side rather than sliding, was cumbersome and difficult to operate in emergency. Visibility from the ground was terrible. The pilot sat very high in the fuselage with the nose angled up, meaning that on the ground, the pilot essentially taxied blind forward, seeing only sky and the tips of the wings. To navigate around an airfield, a Bf-109 pilot had to snake left and right in a sinuous pattern, constantly looking out the side of the fuselage to see where the wingtips were. This put enormous torsional stress on the fuselage during taxiing, and then there was the landing gear. Walker spent hours examining the retraction mechanism, the geometry of the legs, and the relationship between the wheel track and the aircraft's stability. Here, he realized, was where German thinking diverged most sharply from American practice. The Bf-109's landing gear was not particularly narrow. The track was actually wider than the famous Supermarine Spitfire's gear. But the way it was mounted created a cascading series of problems that only manifested when the aircraft was on the ground. The legs were splayed outward at an angle, not just for stability, but because they had to clear the retraction bay when they folded up into the fuselage. This meant that as the aircraft settled onto its landing gear, the wheels ended up towed out at an angle. If crosswinds pressed from one side, or if a pilot made an aggressive correction during landing, the aircraft would suddenly pivot on one wheel. The small rudder, efficient at high speed, but limited in low-speed authority, could not overcome the momentum of a multi-ton aircraft swinging around its main gear. The result was a ground loop, the aircraft's tail whipping around in an arc, while the wings dipped toward the ground, often catching and breaking, the wing tip, or collapsing the gear entirely. Colonel Johannes Mackie Steinhoff had experience with this problem intimately. He had written to American engineers years later that Luftwaffe pilots had lost approximately 11,000 aircraft, one-third of all Bf-109s produced to takeoff and landing accidents alone. Young pilots, especially those rushed through training as the war progressed and German losses mounted, often found the aircraft unforgiving. An experienced pilot like Steinhoff himself could manage it, he knew, to keep the tail wheel locked as long as possible, to maintain directional control, to use short, precise brake applications, to avoid aggressive correction inputs that would trigger a swing. But as German training standards collapsed in 1944 and 1945, with new pilots receiving only 160 hours of flight time before being sent to combat units, the accident rate soared. Pilots who had trained on the Arado 96, with its wide, inward-folding landing gear, found the transition to the Bf 109 particularly hazardous. Walker began to understand something profound during those weeks at Wright Field. The Bf 109 was not simply a fighter aircraft, it was a machine that had been optimized for very specific purposes and very specific pilots. It had been designed in the mid-1930s when German pilot training was thorough and rigorous, when mechanics at the forward airfields were highly skilled, and when the aircraft had air superiority, meaning it could operate from unprepared fields and didn't need to integrate into large American-style formation tactics. The trade-offs Messerschmitt had made were brilliant when those conditions held true. The concentrated structural design made the aircraft light, giving it an exceptional power-to-weight ratio. The splayed landing gear didn't matter much if you were landing on grass fields and had pilots with hundreds of hours of training. The poor visibility from the ground was acceptable when you were parking the aircraft in a protected revetment and leaving it there until combat operations required another sortie. But those conditions had changed. By 1943, the Luftwaffe was fighting a defensive war. The aircraft that had once been a hunter was becoming prey. The German Air Force was being asked to operate under conditions that the Bf 109 was fundamentally ill-suited to handle. American fighters, with their wider landing gear, superior visibility, and more robust construction, could operate from forward bases and damaged airfields. The P-47 Thunderbolt, with its air-cooled radial engine and 2,000 horsepower, was less maneuverable than the Bf 109, but nearly as fast at the high altitudes where the bomber war was fought. More importantly, the P-47 was less vulnerable to combat damage. The radial engine cylinders provided redundancy in a way that the inline engines could not. Then, in the late spring of 1943, something had changed for the Americans. The North American P-51 Mustang, originally designed to British specification with an Allison V1710 engine, had been mated with a Rolls-Royce Merlin power plant. The results were startling. Suddenly, American pilots had an aircraft that could follow the Bf 109 to altitude, match its speed, and outfight it in the extended engagements that long-range escort missions required. The Mustang had the range to stay with bombers all the way to Berlin and back. The Bf 109, with its small internal fuel tank, had to fight near its bases or use heavy drop tanks that degraded its performance and maneuverability. Walker moved through the Bf 109 systematically, understanding how each component fit into this larger context. The wings were thin and beautifully shaped. Designers had used a NACA 2R1 airfoil profile with a thickness-to-chord ratio of only 14.2% at the root, allowing the wing to integrate with fuselage, with minimal disturbance to the airflow. By contrast, American wings tended to be thicker and more robust, sacrificing some of the aerodynamic purity for structural strength and the ability to absorb combat damage. In the Bf 109, a cannon shell through the wing would often mean a catastrophic failure. In a P-51 or P-47, a pilot might nurse a damaged wing back to base. The engine installation fascinated Walker most of all. The German engineers had achieved something remarkable. They had managed to remove or replace the entire power plant in less than 5 minutes. The engine was mounted in a unitized system called the Krafte, which allowed the entire engine, coolant system, and auxiliary equipment to be handled as a single unit. For a fighter operating from forward airfields, constantly under bombardment and requiring rapid turnaround times between sorties, this was genius. An American engine, by contrast, was installed through a series of individual connections and required significantly more labor to service. But the elegance of the installation highlighted another problem. The cooling system for the Daimler-Benz was complex, with a large radiator that could not be easily protected. American air-cooled radial engines, by contrast, needed no sophisticated cooling system at all. The German liquid-cooled engine was more streamlined, contributing to the aircraft's speed advantage, but any combat damage to the cooling system would cause the aircraft to fail within minutes. American pilots learned to target the cooling radiators on Bf 109s, A small puncture wound would eventually prove fatal, though not immediately, giving the German pilot time to nurse the aircraft toward home before the engine temperature spiked and the coolant boiled away. By late July 1943, Walker had made his preliminary recommendations. The Bf-109 was, in many respects, a more elegantly engineered aircraft than anything American designers had produced. The fuel injection system should be seriously studied. The automatic propeller pitch system represented a significant advance. The structural integration and manufacturing efficiency demonstrated by the concentrated firewall design offered lessons for future aircraft. But there were things American designers should never adopt. The splayed landing gear geometry was a fundamental mistake. American aircraft would maintain their wider, more stable landing gear configurations. The cramped cockpit and poor visibility were problems that American designers had solved more successfully. The decision to use a liquid-cooled inline engine, however efficient, was vulnerable in combat in a way that air-cooled radials were not. Most importantly, Walker reported that the Bf-109 represented an aircraft designed for a specific phase of warfare, the phase when Germany had achieved air superiority and was fighting on its own terms. In the new phase, where the Americans had seized the initiative and German aircraft were constantly under attack and operating from threatened bases, the Bf-109's advantages had become its handicaps. The light construction that made it fast now made it fragile. The high performance that had been unmatched in 1940 and 1941 was now matched and, in certain key parameters, exceeded by aircraft like the P-51 Mustang. By 1944, the truth was undeniable. The Mustang, with its Rolls-Royce Merlin engine producing 1,590 horsepower, its 6 50-caliber machine guns, its huge internal fuel capacity and auxiliary drop tanks providing 1,650 miles of range, and its superior visibility, had become the dominant fighter over Europe. German pilots like Kurt Bühligen, one of the highest-scoring aces of the Western Front, grudgingly admitted what had become obvious to every Luftwaffe pilot. The Bf-109 could still outturn the Mustang, and in the hands of a skilled pilot, it could still achieve victories. But numerically and tactically, the advantage had shifted decisively. For every skilled German pilot with hundreds of combat hours, there were now 10 American pilots who had trained on a network of advanced flying schools and had the confidence of air superiority behind them. The Mustang's lighter armament, optimized for air-to-air combat, proved sufficient to destroy the Bf-109, while the Bf-109's cannon-based armament, increasingly beefed up with 13mm and 20mm weapons as the war progressed, was actually disadvantageous in fighter versus fighter combat. The turning point had come in the spring of 1944. In February and March of that year, a series of massive daylight bombing raids over Germany suffered extraordinary losses. Over 1,000 bombers damaged or destroyed over a period of weeks. But the Luftwaffe had expended enormous resources achieving these victories, and they didn't have unlimited resources. By March 1944, when General James Doolittle released American fighters from the requirement to stay close to the bomber formations and instead authorized them to range ahead on fighter sweeps, the trajectory of the air war was effectively decided. The Bf-109s and FW-190 could still fight, could still on any given day bring down American aircraft through aggressive tactics and skilled flying, but they could not stop the tide. The war of attrition, which Germany could not win given American production capacity and the endless supply of trained pilots the American system produced, had begun in earnest. The capture of the Bf-109 G6 at Wright Field that summer represented more than just an opportunity for American engineers to understand German engineering. It represented a snapshot of a machine at the moment when history had begun to pass it by. The aircraft that had dominated the skies of Europe in 1940 and 1941, that had enabled Messerschmitt to become a legend among pilots, was gradually being superseded by newer designs that learned from the Bf-109's mistakes while maintaining its performance advantages. American aircraft designers would ultimately not copy the Bf-109's concentrated structure or its splayed landing gear geometry. Instead, they would take its lessons and fold them into aircraft already in development. The P-47 Thunderbolt remained the premier American fighter for ground attack and low-altitude combat throughout the war. The P-51 Mustang evolved through continuous improvement. The P-51D introduced the bubble canopy that provided 360-degree visibility, a direct response to observations about the limitations of the German cockpit design. Future American fighters would benefit from the Bf-109's experiments with fuel injection, with automatic pitch control, and with structural integration. The Me-262 jet fighter that would eventually emerge as Germany's last hope represented an acknowledgement that piston-engined aircraft, no matter how well designed, had reached the limit of their potential. But by then, the war was effectively over. In 1943, when Walker's team was examining Messerschmitt's masterwork, the Bf-109 still possessed advantages that could not be overcome by numbers or tactics alone. The aircraft that First Lieutenant Chuck Yeager shot down, the first of 13, confirmed kills that would eventually make him one of America's greatest test pilots, was a machine that had proven its worth in the skies over France, North Africa, Eastern Europe, and the Mediterranean. It had carried aces like Erich Hartmann, who would ultimately record 352 confirmed kills, more than any other pilot in history. The Bf-109 had been a teacher for an entire generation of German pilots, and in their hands it had written some of the most dramatic chapters of the air war. Yet standing in that hangar at Wright Field, examining the captured machine with instruments and calipers, American engineers understood something that seemed paradoxical. The Bf-109's greatest strength was also its greatest weakness. It had been optimized to perfection for a war that Germany could never win. The very design choices that made it superior to anything the British and Americans could field in 1940 were the same choices that made it vulnerable to the designs of 1944. The splayed landing gear that was so problematic had been chosen because it allowed the wings to be removed for maintenance. The thin wings that gave the aircraft speed had been designed for structural simplicity, not combat survivability. The powerful engine that dominated early engagements had been sized to fit within an airframe that was pushing the boundaries of how small a fighter could be. In the end, the Bf-109 was a monument to what could be achieved when resources were unlimited and imagination was uncompromised. It would be built in greater numbers than almost any other fighter aircraft in history. Over 33,000 airframes would roll off German production lines by the time the war ended. But those numbers would ultimately tell a tragic story, that even the finest aircraft, flown by the finest pilots, could not overcome the weight of history. The momentum of a manufacturing system stretched to its breaking point, and an enemy that had learned to turn their weaknesses into strengths. The Bf-109 had shown the world what was possible. The P-51 Mustang would show the world what was necessary. And in the vast distances over Europe, where the war would be decided in 1944 and 1945, it would be the American aircraft that would carry the day.